Have you ever wondered how can you grab your cup of coffee so accurately? Or even how football players receive the ball seamlessly while running? How can we interact with objects around us, judging their distance from us and their accurate position around us in part of a second? That's what we're gonna know in today's episode. Brain is a powerful organ. It controls almost everything in the body, such as heat regulation, breathing, hunger, heart rate, and so on. Also, it controls our perception of the surrounding environment and our movements. The process of grabbing something we see and want to reach involves three mental mechanisms: spatial awareness, depth perception, and eye-hand coordination.
Spatial awareness refers to an individual's ability to understand and perceive the spatial relationships between objects, as well as their own body in relation to those objects. It involves being aware of one's position, movement, and orientation in space, and being able to navigate and interact with the environment effectively. The mechanism of action underlying spatial awareness is complex and involves the coordination of multiple brain regions and sensory systems. It involves the integration of information from various sensory modalities, including vision, audition, touch, and proprioception. Visual cues, such as the relative size and position of objects, provide important information about spatial relationships. The visual system processes information about the location and movement of objects in the environment, and the brain uses this information to construct a mental map of the surrounding space. While auditory cues involves the brain to use differences in the timing and loudness of sounds received by the two ears to determine the location of a sound source in space. And this process is called the binaural hearing. The sense of touch also contributes to spatial awareness. The skin contains receptors that are sensitive to pressure, vibration, and temperature, which provide information about the shape and texture of objects in the environment. For example, when reaching for an object, the brain uses information from the sense of touch to guide the movement of the hand and position it accurately. Proprioception, or the sense of body position and movement, is also crucial for spatial awareness. Proprioceptors located in the muscles, joints, and tendons provide information about the position and movement of the body in space. The brain then uses this information to coordinate muscles' movements while maintaining the body's balance.
The integration of information from these different sensory modalities occurs in the parietal cortex, a region of the brain that is involved in spatial processing. The parietal cortex receives input from the visual, auditory, and somatosensory systems, as well as from the motor system, and uses this information to construct a spatial representation of the environment. Depth perception is the ability to perceive the distance of objects and the spatial relationship between them. The mechanism of action for depth perception involves the integration of visual information from both eyes, which is known as binocular vision. When an object is viewed by both eyes, each eye receives a slightly different image of the object due to the distance between the eyes. This is known as binocular disparity. The brain then combines the two slightly different images into a single three-dimensional image, which provides information about the depth and distance of the object. Depth perception involves the integration of information from both eyes, as well as other cues such as texture gradient, interposition, and motion parallax. Binocular cues are the most important cues for depth perception, which involve the use of both eyes to create a sense of depth. These cues include retinal disparity and convergence. Retinal disparity refers to the slight difference in the image that is projected onto each retina due to the distance between the two eyes. The brain uses this difference to calculate the distance of an object. Convergence, on the other hand, refers to the inward movement of the eyes as they focus on an object that is closer to the viewer. The degree of convergence required to focus on an object provides a cue to its distance from the viewer. The brain integrates different cues to create a sense of depth through a process called stereopsis. Stereopsis refers to the process of combining the slightly different images that are received by the two eyes into a single three-dimensional image. In the visual cortex of the brain, there are specific neurons that are sensitive to the disparity between the images received by the two eyes. These neurons compare the input from the two eyes and use the differences to calculate the depth of objects in the visual field. And this process is called binocular disparity processing. Eye-hand coordination is defined as the ability of the eyes and hands to work together in a coordinated manner. It is a fundamental skill that is required for activities such as sports, writing, drawing, and using tools. Good eye-hand coordination allows an individual to accurately perceive and respond to visual information and manipulate objects with precision.
Eye-hand coordination is a complex process that involves the integration of visual perception, motor skills, and cognitive processing. In order to perform a task that requires eye-hand coordination, the brain must first receive and process visual information from the eyes. The brain then sends signals to the muscles of the hands and arms to execute the necessary movement.
The mechanism of action involves multiple areas of the brain, including the visual cortex, motor cortex, and cerebellum. When an object is seen, the visual information is transmitted from the eyes to the visual cortex, where it is processed and analyzed to determine the object's location, shape, and size. This information is then transmitted to the motor cortex, which generates the motor commands necessary to control the movement of the hands and fingers. The cerebellum plays a crucial role in coordinating and refining these movements. It receives input from the visual and motor cortices and uses this information to adjust the movement of the hands and fingers based on feedback from sensory receptors in the muscles and joints.
It is not an innate ability, but rather a skill that is developed over time through practice and repetition. Children develop eye-hand coordination through play, such as catching and throwing a ball, playing with building blocks, and drawing with crayons. As they grow older, they refine and improve their eye-hand coordination through more complex activities, such as playing sports or learning to play a musical instrument.
Eye-hand coordination can be improved at any age through practice and exercises. There are many activities that can help improve eye-hand coordination, such as playing sports, video games, or doing puzzles. These activities challenge the brain to process visual information and respond with precise movements. It is also essential for athletes, such as basketball players or tennis players, who need to be able to react quickly to their opponent's movements and accurately hit a ball. Also, people who work with tools, such as carpenters, surgeons, and mechanics, need to have precise control over their tools in order to perform their job safely and effectively.
Spatial awareness and hand-eye coordination are closely related because both involve the ability to understand and interact with the environment through movement. Developing good spatial awareness can help improve hand-eye coordination, as it allows individuals to better understand the spatial relationships between objects and their own body, which can help them to more accurately and effectively perform tasks that require precise hand-eye coordination. Similarly, improving hand-eye coordination can also help to improve spatial awareness, as it requires individuals to focus on the relationship between their own body and the objects they are interacting with.